Hello everyone, I'll be presenting Integrative Few-Shot Learning for Classification and Segmentation. This work was done by Taeyeon Kang and Min-Soo Cho. Few-Shot Learning is a machine learning problem with limited supervised example for a target task. In computer vision, the popular few-shot learning tasks include classification, semantic segmentation, etc. This is an important machine learning problem which can evaluate model generalization and reduce labeling cost. But the existing few-shot learning tasks some limitations in the problem setup. The existing few-shot classification assumes that there exists a single object class, therefore it cannot perform multi-label classification. On the other hand, the existing few-shot segmentation assumes that the support and query classes are always the same. As a side effect, few-shot segmentation models are often trained to segment out any salient object on a query image. In this example, the ground truth is not to segment anything, since the word is irrelevant to the airplanes. To address their limitations, we present a new integrative task of few-shot classification and segmentation, which combines the two tasks into an integrative one. This task generalizes the two existing few-shot learning tasks by allowing the absence of the support classes as well as allowing the multiple positive ground truth labels. We also propose a learning framework to solve this task and name it as Integrative Few-Shot Learning Framework. It generates class-wise foreground maps and makes prediction on top of it. For classification, the foreground maps are max pooled and binarized by a certain threshold. For segmentation, the foreground maps are merged by averaging the background maps. This learning framework can be formulated with class tag supervision only. In this case, it is a weakly supervised setup in the segmentation perspective. To make reliable foreground maps, we adopt self-potential learning on top of the correlation tensor between the support and the query feature maps. It learns to transform the correlation to a foreground map by gradually squeezing the support dimension on each query dimension via striated self-attention, and we named it Attentive Squeeze Network. Here are some qualitative segmentation results of ASNet trained with iFSL on FSCS. These examples cover all inclusion relations of the query and the support class set. The first case shows that no class of interest exists in the query image. And the second and the third case shows that some support classes are in the query image. And the last case shows that all support classes appear in the query image. The trained model accurately distinguishes what are relevant or not based on the semantic relationship between the given support set. These are the common failure cases of the conventional few-shot segmentation models in our task. ASNet trained under the conventional setup gives foreground prediction on any existing object, resulting in unclear mask prediction, whereas ASNet trained under our setup produces clean mask prediction. To fairly compare ours with others on FSCS, we reproduced 3 existing few-shot segmentation models and trained all of them under the iFSL framework. The result shows that ASNet outperforms the state-of-the-art method on FSCS. Here, ASNet sub W denotes the class tag supervised models, which is weak in segmentation but effective in classification. FSCS is multi-class scalable and its number of classes can be arbitrary many. The plot compares 4 methods varying the classes from 1 to 5. We measure the task transferability between the conventional few-shot learning tasks and ours. The model trained under FSCS show only a small performance drop when transferred to the other tasks. However, the conventional few-shot classification cannot be reduced to the multi-label classification. Also, the conventional few-shot segmentation models suffer from a severe performance drop when transferred to FSCS. Our work is live on the poster session 2.2. Feel free to check out our GitHub and paper online. Thank you for listening.